Okay, we want to prove that polynomials of odd degree always have at least one real root. So we have, let's see, p of x equals, we'll say, a n x n plus a n minus 1 x n minus 1 all the way down to a0, where n is odd and I is real, where of course I is between 0 and n. All the coefficients are real, and it's an odd power for n. Oh, and we should also say that a n is not 0, because then the polynomial would be possibly not of odd degree then. And of course I is natural numbers and so on. You get the idea here. So we have a polynomial of degree n is odd, the coefficient on xn is not 0, and all the coefficients are real then. Okay, now let's have a look at what happens when x goes to infinity. So, well, let's say we look at the limit as n goes to infinity of px over p minus x. So that is, if I'm being really clear about it, actually what I'm trying to look at is what happens when n goes to positive infinity, and then when n goes to, not n, I'm sorry, x goes to positive infinity and x goes to minus infinity. I want to see what happens to the polynomial when we have very large positive and then very large and negative. So I can write this as just limit x goes to infinity of px, and then here limit x goes to infinity of p minus x. That will equal the limit as x goes to infinity px over p minus x, which will equal the limit as x goes to infinity of a n x n plus etc 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 all over a n minus x n plus etc etc etc. That will equal the limit as x goes to infinity of a n x n plus etc 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 all over minus a n x n plus etc etc etc. This is because n is odd. Since n is odd, we know we can pull the minus out then. If I divide each term by xn, and then this would become limit x goes to infinity a n, and then the next term would be plus a n minus 1 over x, and then x squared and so on, and then this would be minus a n plus a n minus 1 over x, and the next one would be a minus. The signs are alternating here. When x goes to infinity, then you're left with a n plus 0, etc 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 over minus a n plus 0 minus 0 etc etc etc, which will just equal minus 1. So what does that tell us? Or maybe I'll try and squish it in a box here. So that means then the signs differ at the far left and the far right. So the signs are opposite at infinity and minus infinity. So then the what's it called? Um, intermediate value theorem uh, implies then that 0 must be reached between minus infinity and infinity. So if they are opposites in signs, one end is plus and the other end is minus. It doesn't matter what the number is, a positive number and a negative number. And then at infinity, it'd be positive infinity and negative infinity. But the IVT implies that 0, being a value between minus infinity and plus infinity, must be reached. So somewhere on the x-axis, this polynomial has a value of 0, which means therefore it has a root. Therefore, there exists a root. Okay, and that ends that one.